Hello everyone. Today in this video we're going to be going over the basics of functions and subs and how we implement them. Uh, the thing we're going to be focusing on today is just why we create the function, the very basics of how we create arguments for the function, and why they are useful. We will also briefly cover what a module is and how that relates to our functions. So the very first thing is that we want to go over is what is a function and what is a sub. So we have a blank form here. We've not put anything into it yet, and we are going to create a function. And so we're going to start that off by just doing private function. Now, whenever we create a function, we need to name it. For this example, we're going to do a very simple function. It will be a sum. So it's going to be private function sum. And that's it for right now. So this is our basic structure for creating the function. Before we go any further at all, we're also going to create a sub. And so this is going to be done with private sub, and I'm going to call this display. So now that we have these two set up, we can see how we create the function and the sub. And so now we were going to talk about why we use these and how they're implemented. What a function is, a function returns a value that is performed by a calculation inside of the function. So if we think about this, a function always returns the name of the function. And so what I mean by that is our output of the function sum is going to be a value that is named sum. The function is always going to be returning a value. And so the difference between the function and the sub is that the sub performs a sub procedure. That's where the name sub comes from, is it's a sub procedure of code. But we are not necessarily needing it to produce a value. You'll see here that I've named this sub display. And what this sub is going to be whenever we set it up is it's going to be a way for us to display some data inside of a text box. And so the key difference here is that the function must return a value, where the sub can just perform a procedure. It executes code, but it is not necessary for it to return a single defined value. So there's a few key elements to each of these. We see this is the general format. So we say a private function, and in this one we call it sum. So this is the name of the function, sum or display is the name of the sub. And then we have end function or end sub respectively. The only thing here is we have these parentheses that's on the name. And so what these parentheses are is these represent arguments into the function. Arguments are anything that we input into the function whenever we call it for use. And so this will be a little bit more obvious whenever we actually call the function, but for now we're going to work with setting it up, and then I think it'll come together. So if we think about for sum, we can think about arguments as our inputs into the function. Then the sum, so the variable sum, is going to be our output, and we're going to have two inputs into sum, right? We're going to be adding two numbers together. So the way that we set this up is we use an operator called Byval. And so there's actually two ways you can do these. Byval is going to be that they cannot change the value of the code. And so what I mean by that is, whenever we set up a function, if we call Byval, the value that we pass to the function, so let's say we have a variable called n, and it's 5. If we use Byval, the function can take that value of 5, but it cannot change the original value. So the value that was in the program cannot be changed. It can be worked with inside of the function, but it cannot be changed in its original form. If we used byref, which is the other option, byref means that we can change that value. If you see here, we actually get a little help from VB, and it says that byref specifies that an argument is passed in such a way that the called procedure can change the underlying value of the argument in the calling code. That's fancy talk for saying that we can change the original value that was passed to us. So let's say for the value of n, we want to increase that value. So we can call that value n and work with it, and then whenever we change the value of it inside the function, it will change that value of it in the original form that we used it in. So for this case, we're going to be using Byval, because if we think about sum, we're not trying to change the original value. We just want to bring in the value, we want to add the two values together and output sum. We're not actually trying to change the originals. So the important thing whenever you're writing the arguments is to remember that the two arguments, in this case you can have infinite number of arguments into a function, are going to be the names that we use inside of the function. So I'll go ahead and demonstrate this quickly. So if we say Byval sum1 as double, and every time we put a comma, that's a new argument into the function. And we do Byval sum2 as double. What we've done here is we've created two arguments for the function. So sum now has two arguments. The first will take on the value named sum1, and the second one will take on the value of sum2. Both have been defined as doubles. Now, the only other important thing we need to do, and this is not necessary to do in function or sub, but it is a useful tip just to head off any problems, is if we put as double at the end of this outside of the parentheses, that is going to specify what sum must be returned as. So if we didn't have this here and we ran this code, sum is automatically going to become a double because both of the input arguments are doubles. This is complicated if we type in sum1 as an integer and sum2 as a double. Now VB should be able to handle this, but the only problem we have is that this integer and the double may conflict, and it's not going to know exactly which way we want sum to be output, as an integer or as a double. So in this case, if we specified that we want sum as double, it would account for that, and it's going to make necessary corrections to ensure that sum is returned as a double. But in this case, we have both of our inputs as doubles, but we're still going to use this as double just because it's a good practice to make sure that you always know you want to specify what you want your output to be in. If you want sum to be as a double, it's necessary to explain that. So now that we've have these our arguments, remember the arguments are inside of the parentheses and they're separated by a comma, so therefore we have two arguments. We're now going to actually create the function, and so this one's pretty simple. Again, we don't need to define the variable sum because it's the name of the function. The name of the function is a variable which will be returned. So it's created itself. Again, you can think of this as if you ignore all of this highlighted code, you can see that we have a declaration here, sum as double. So we've declared that variable. So sum here is going to be equal to sum1 plus sum2, which are our two input arguments. Now, the common problem that I come across whenever I explain this to students is they don't understand why we're defining these arguments. They don't understand what the point of this is. And so I'm going to make a quick little demo of why we have to do this. Let's say we dim two variables, and I'm going to call this num1 and num2 as double. So we define two values. We're going to quickly, we're going to go to our form. I'm going to add some controls in. So looking at our toolbox, I'm going to add a button. I'm going to add two text boxes. I'm going to name this first text box. Go to the properties. We're going to name this text box 1, text box 2. I'm not going to change these names just because they make pretty good sense here. We're going to name this button compute. We'll change the caption on it as well. So now we have a little bit of a setup here. I'm going to add a label just so that we remember what we're talking about. So this will be our num1. If we add another label, this will be our num2. So now we have this set up. So if we come back here to our actual code, we could set num1 whenever, and we would actually need to create our button first. So now that we have our so now that we have our button sub, we can, inside of this, we can set the values of num1 and num2 equal to the value of textbox1.text and num2 equals to textbox2.text. So now we've assigned the values of num1 and num2, and we have those values available to us. So now, whenever we look at this, this is where the arguments are very important. Because if I wanted to call the sum function, I call it by typing sum. I'm going to specify my two input arguments. So you think here I've defined this sum1 as double and sum2 as double. So if I type in num1, comma, num2, I have filled both of the arguments of this function. In this case, the reason why we do this is num1 will pass its value to sum1, and num2 will pass its value to sum2. And the power of doing this and why we do it is we do not need to know what the user's variables names are that they're passing into it. If you think in this case, it's very simple. I mean, we could just write a sum code inside of this button. But think about functions that are much more complex than this, that have thousands of arguments to them. In those cases, we don't always know what the user's variable inputs are going to be. For example, if we renamed these, instead of num1 and num2, we named it something else, the names that we have here do not affect this function at all. Because we are using inside of the function the values of sum1 and sum2, which are constant. These arguments do not change. The arguments we use inside the function will always be sum1 and sum2. However, we can pass any variable name whenever we call the function, because we're assigning, in a way, num1 equal to sum1 and num2 equal to sum2. And then after those values take on these variables, they can be used. And this is where the byref and byval come in handy. Because we say byval, sum1 is taking on the value of num1, but it is not changing num1. If we wrote this as byref, sum1 would take on the value of num1, and then it could still actually change the value of num1 in the button sub. So this is why functions are so important, is they allow us to make a very general template. If you look at this, like I said, we're never changing anything inside this function. It is always going to be sum is equal to sum1 plus sum2, but it allows us an infinite amount of variable names that can be input as arguments, because they do not matter. All it is doing is passing the value that we input in the function into these two arguments and applying them into the function. So for this example, if we click this button, it would take on the value of num1 and the value of num2, and then we call the function by writing the function's name. Inside the parentheses, we specify the first argument, comma, the second argument. This is going to return a value. The only thing is as of right now, it's not actually going to paste anything anywhere. There's no text box that we have. So to fix this, we're going to create a quick text box. We're going to make this a multi-line text box for no specific reason. And this is going to be our answer. So I'm actually going to rename this to text box answer. So now if we go back to our code, we now see that we have a sub that's called display. And we talked about how a sub does not necessarily have to return a value. It just performs some sort of procedure. And so in this case, we can use a sub to display this data. We've created a function to find the sum. Now we're going to use a sub to display the data. And if you think about why we're using a sub, is because, again, we're not actually returning a value. We're just wanting a sub procedure of code. In this case, we would just want to post a value into a text box. So the way we're going to do this is going to be a little bit creative, actually. We are going to use display to bring in a text box. The way in which we are going to do this is we can use multiple different things as inputs for subs as well as functions. So in the two examples that we have just done, we have used double, and we used an example with integer as the data type that we were bringing in. It's important to know that we can also use things like objects. If you're not familiar with the terminology, an object is going to be anything that we use that is an actual object inside the program. And I know that sounds a little bit redundant, but what I mean by that is a text box answer, for example. This is an object. It's an object-oriented language, so these are our objects that we are working with. In that way, we can actually refer to things as objects inside of sub and function arguments. So I'm going to use an example just to explain this. So we here can do a Byval, and I'm going to call this just text box as, and instead of double or integer, we're going to say as object. It's going to be our first argument. Now, if we think our display is going to be displaying our sum inside of a text box. So we're going to want to have our other value, Byval, and I'm going to call this value as double. Now, the reason that we want this to be a double is our sum is returning as a double. So we want to make sure that we're bringing in our sum as a double. And right now you may be thinking, isn't this a little bit redundant? We've already calculated sum. Why are we creating an argument to bring in the sum? I'll demonstrate that here in a minute. Basically, even though we've already created a function to calculate the sum, we still need to pass that value to our display sub so that it can display it. So now that we have this display sub set up, again, we can use text box. It's not referring to any specific text box. It's just a general variable name that we are using to explain any text box that is passed in. So if we pass a thing that says text box answer, it will take on the value of text box, and if we pass sum to here, it will become value. Because whenever we have our sub here, what we're going to say is textbox.text equals to value. So we're setting whatever text box we bring in is going to be converted to the name text box, and whatever sum we put in is going to be converted to the name value. Again, see how our sub and function are very general. They're very not specific. However, our variables inside of the compute button, which is our local sub, is very specific. So so far we've only created the sum function. We have it sitting here, but it can't actually display anything. So now that we have this display sub set up, we can actually put this to work. So we're going to write display, so we're going to call our display function. Our first input is going to be text box answer. Our second argument is going to be sum. So if we add this last parenthesis, you should be able to see how this makes a little bit of sense. Our private function sub has sum1 and sum2 as its arguments. We call sum using num1 and num2, which becomes sum1 and sum2. Those then are added together to return the value of sum. So this second argument is going to become the value of sum, which has been defined in our display function as a value. The first argument is text box answer, which is passing the text box answer into the display as an object that's becoming the value of text box. So we can then say textbox.text is equal to value. whenever we call this whole function, or this whole sub, the display sub, it's actually going to display the answer. So if we run this program, we can actually show how this works. So if I type in a 1 and a 2 and press compute, the answer shows up in the text box. Now, you may be wondering, this is the other question I get from students, is why did we go through all of this effort? We could have simply just put all of this underneath of the compute button and called it a day. It would have been very simple, saved us a lot of work, and it would be much less complicated. Why do we do it? The simple answer is that these are very simple functions and very simple subs. And yes, it would make more sense just to do it underneath of this button. But let's think about what it would be like if we're creating a program for Microsoft, for example. Visual Basic uses tons of functions and tons of subs that we do not see inside of this interface, but is used in all of the things we do. And if we had to recreate those every time we made a program, it would be a daunting task. And so what functions and subs allow us to do is to create these generalized templates that can be used for anything. If you think here, we do not care what the value of what the user puts in, as long as they are the same data type and we convert them to these values that we always know are true. We know that sum will always be equal to sum1 plus sum2. It doesn't matter what the user names their variables, because whenever they call the function, we convert them to these names. And that's the power of the function, is that we can create a general use template that can be used for multiple uses of the code. And so, going off of this, we're now going to talk about the module. All the module is if we go to Project and we click Add Module, we are actually going to have the option to add a module to our code. I like to call my module my lib, and what that stands for is my library. In a lot of other languages, the module is actually referred to as the library. The library is where all of our functions and the subs reside. So what the purpose of the module and the reason why we use it is, everything inside of a module, we can actually view our Solution Explorer real quick just to kind of explain this. If we look over here, everything that's inside of this module is accessible to every form that we have inside of this project. So this is a bad example because we only have one form, of course, but imagine that we have 10 forms and we all need to sum across all of them. Instead of having to create or copy and paste this function into every single one of them, if it is inside of the module, all of the forms can access it. It's a global function now. Now, the important thing to know is that, or what you may ask is, but these variables aren't global. How can it work? The answer is, we are defining these variables locally, and we are calling them locally. Whenever we call this function, even if this function is located inside of this module, it's going to pass these values into the function. And so it's going to get around that problem. So to demonstrate this, we could take this function, this sub. I'm going to cut these from this form. I'm going to move them. You'll actually see we're getting some errors, right? These don't exist anymore. What's the problem? We're going to come to the module, and I'm going to paste them. See, we don't have any problems because we've used generic variables. All of them are exclusive to the function and the sub, so there's no mismatch, there's nothing missing. Now we had those errors on the form, so let's go back and look. Ooh, we still have errors, but we don't. Because what's happening is we define these as private whenever we made them inside of the form. So all this is going to take is to make a very quick change from a private to a public function. This is necessary because we put it inside of the library or inside of the module, and so now we need to make it public for all of them to see. So if we go back to the form now, our error has been fixed, and we are actually able to access these functions that are inside of the library. We can actually run this code quickly and just verify that everything still works the same, and of course it still works. So you see, the important thing here is that the reason why we create the module at all is because functions and subs are general use components. They are used to reduce our workload. The important thing that we're trying to do is we don't want to have to recreate this code every time we need a sum. We don't have to keep typing sum over and over and over. And in this way, all we have to do is just call sum and put in our two values, and it's going to create it. In a similar way, if we had a different a different form that we had a different name for text box, right? We could still use the display function, type in the name of that text box, type in the name of their sum variables, and it would paste to their text box because it is in a module. It's accessible to all of them. And so that's the very basics of functions and subs. I hope this helped a little bit. If you have any more questions, feel free to contact me, and we'll try to have a subsequent video on some of the more advanced features of how functions and subs work. Thank you.